Hey, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a problem.
Well, Houston, we don't have a problem. Hey, today we want to mainly talk about, well, one topic, but I have a quick topic I want us to address. We sort of briefly addressed it in the last video, and that is, what is science? And we've said this in class, we've talked about this, but it's just super important to review what this means. Science originates with questions about the natural world. So we're not going to ask questions about faith or what like that. It's going to be about the natural world. So we're going to look at the natural world and ask questions. But we're going to use patterns, right? We're talking about patterns and our observations to construct explanations. Number 3, if you will, scientists make their explanations public. This is actually a thing that scientists do in order to determine the best explanation. So it's open to scrutiny so that other people can look at this and say, I think your dad is wrong, or whatever. So that's in an ideal world, that's how science should work. And they critique the explanations proposed by other scientists, which I already addressed, I guess, so that people can say, I don't think this is a great idea. There was a classic example a number of years ago, is there's this guy in Utah, a doctor professor guy, who said he discovered something called cold fusion. And cold fusion is like the thing that could solve all of the world's energy problems. And he did not publish it in the normal way. He just sort of advertised it or somehow, out on the internet, as opposed to, through scientific channels. Long story short, he had not discovered cold fusion. A lot of scientists could not reproduce his experiment, and it was a big flop. It's one thing to make a claim, and it's nothing because the other scientists said, I can't make this happen, and the science doesn't work, or whatever. So it's important to have there's an opportunity for it to be critiqued and there to be explanations. All right. We're, of course, looking at finding patterns. And the thing about a pattern that helps you know if the model is good is that it can predict the future. So our big question of this video is, how do I predict the future by finding patterns and measurements? That's the big questions. Because the pattern that you're looking for tends to be a mathematical equation. So can your mathematical equation predict future events? That's really big. And then the second focus of this video is going to be, I want to show you how to use Desmos, the Desmos program, to determine. So once you've collected a series of data points, you're going to use this Desmos program to help you determine what the mathematical relationship is. Let's take a look. So how to use Desmos. So when you're looking at Desmos, I've just got a blank Desmos thing opened up. And in our situation, what you're going to do is want to click plus and add a table. And if you add a table, we've got x and y. Your x, of course, is going to be your independent variable. And then your y is going to be your dependent variable. So I'm just going to put some numbers down here. And what we want to do is, but these will actually be your data points. So, maybe these are seconds. Or whatever, right? It's something, I'll go 7, and then I'm going to say this is 2, 4, notice what's happening, 6, 8, let's say 7.8. I'm not going to make the data perfect. 10.3, 12.4, and 15.9. And now I have a series of data points, and you can see them, but my graph only goes, here I'm going to zoom out so I can see my data points. But now what I want to do is I want to add an equation. So I can add an expression, and it's going to be y equals, and now we have to decide, I'm going to say x. And then what I can do is I can put a C here, and the slider is C. Now watch what I can do is I can move this around, and I'm trying to draw the line of best fit. Now I'm making an assumption that this is what we call linear expression. It just goes up. But we do have this sort of weird point right here, because it could also be another equation. Let me add another equation. F expression, we can say y equals cx squared. All right, and I can click here. I want to add a slider here. How to make C? C's already there, I guess. Yeah, there we go. so that one was starting to look quadratic, isn't it? Look at the, if I move the C, I'm changing the value of C. Sometimes when you do your data points as a note, you may need to adjust. I've got C here from negative 10 to positive 10. It might be from, negative 0.1 to positive, 0.1. And if I click away from that, then I can change it, and it never matches. So sometimes you've got to change the range. This one is just going to go, let's say, from 0 to 10. And step, doesn't matter. Now I can say I have 0 to 10. If you're looking at these graphs, you see that clearly the blue line isn't working. Ultimately, what I'm trying to do is find the equation for the line. So if we assume this was linear, I might kind of pick this, and that means, and which one is it? It's the black line. The black line is y equals cx. So the c would be, or the slope, right, is going to be 2.16. Now you may have to say cx plus, plus b, and you can add a slider for the b, and the b, of course, is the y-intercept. So maybe we need to move around with that. So you may need to figure out, and the same thing here with cx squared, I can say plus dy dx, add a slider for d, plus b. And b's already a slider. And so I have multiple sliders. Your goal is basically to find the line that best fits, and b doesn't change. I mean, this one goes to the origin, so that's easy, I guess. So that's easy to say, but sometimes you've got to, yeah. The point here, guys, is that you can draw this, and your goal is to use Desmos, is to find the equation that best matches the data that you have, and that gives you the mathematical expression for the phenomena that you're studying. So there you have it. We've got a situation where we want to learn about these patterns, and we want to determine them in a mathematical expression, and we're going to use the program